First of all, welcome everyone to this now third webinar on urban forests. And today I'm really happy to welcome Alec Foster to talk about his work on volunteer geographic information, urban forests and environmental justice, a topic that I think is really exciting, and I'm really looking forward to hear more about this and see how we can link some of these issues to the work we do at SLU. Just as a little bit of background information for you, this webinar series is organized by two of SLU's future platforms, Urban Forests and Future Forests. The SLU Future Platforms promote transdisciplinary research, education, and collaboration for a sustainable future. And we have platforms on one platform that is linked to each of the faculties, but they're all working cross-faculty. And well, Urban Futures and Future Forests are two of these platforms. And what we really also want to do within these platforms is to try to improve collaboration between researchers and society. So really kind of promote researchers to talk with each other and researchers to talk with society. And the whole kind of idea behind these webinars, this webinar series is also to try to both improve kind of communication among researchers within SLU, as well as kind of come up with new ideas how we can reach out to society. And I think today's webinar really nicely links to that. Please, Alec, the floor is yours.
Wonderful. Well, thank you so much for having me. I'm excited to revisit some of my research. This kind of started out as a side project when I was doing my dissertation in Philadelphia, and it's funny how these things kind of have afterlives, but it's really fun to revisit and rethink about some of my work on volunteer geographic information, urban forests, and environmental justice. So I want to start by thinking about what volunteer geographic information, or what I'll refer to throughout the presentation as VGI is. There's so many kind of terms now, whether it's citizen science, participatory science, public participatory GIS, and they're all kind of interrelated, but what I'll be talking about is volunteer geographic information, which following Sarah Elwood and her colleagues, I define as geographic information acquired and made available to others through the voluntary activity of individuals and groups. And people often make the point that this isn't necessarily anything new. Often the Audubon Christmas bird count that's been happening since 1900 is cited as an early and long-running instance of volunteer geographic information. But there's been exponential increases in the amount of VGI available with advances in Web 2.0 technologies that make it very easy for our participants to generate their own georeference content and data. So we can think of things like geotag tweets, digital humanitarianism, and for this presentation, urban forest volunteer geographic information. So with the advent of VGI, people have both hailed it as presenting a lot of opportunities, but also some concerns have been raised. In terms of opportunities, if more people are creating geographic information, it can improve our knowledge of the world, and specifically in the realm of urban forests. Urban forest traditional data collection methods are quite expensive, time-consuming, whether on-the-ground tree inventories, sampling. Most major US cities do urban forest analyses via sampling, or using remotely sensed data collection like LiDAR. The cost can be prohibitive and prevent up-to-date knowledge of a city's tree canopy. VGI has also been hailed as something that can increase equity by widening the ability of individuals to create geographic information. Places, people, and things that have been neglected by expert knowledge can be represented. Furthermore, people have the opportunity to participate in knowledge creation, increasing procedural equity as well. However, despite these opportunities, several concerns have been raised. There's questions of the quality of geographical information. There's interesting concerns about the volunteered aspect of it, right? This is not necessarily official data, and people don't necessarily trust it. Interesting questions of knowledge politics, who gets to create data and whose data is valued, whose data is trusted. Most research on the quality of VGI has been done with OpenStreetMap and shown that it is pretty good and pretty similar to the official data. Despite the potential for VGI to increase equity, differential access to information communication technologies also presents concerns around who has the ability to contribute to VGI, and there's potential and concerns around the digital divide actually increasing inequities. So for those unfamiliar, the digital divide has long been a topic of research policy. Basically looks at the lack of access to information communication technologies. Here's a couple data sets from the US. On the left, we have data from the 2015 American Community Survey looking at percent of households with school-aged children who don't have a high-speed internet connection. We can see overall it's about 15%, and there's racial disparities in that access. And then if we break it down by income, households with annual income less than 30,000, more than a third of them don't have access to high-speed internet connection. And even within that, there's disparities based upon racialization. On the right, we see that it's not just an urban issue, which is often how the digital divide is portrayed, but also from a 2018 Pew Research survey, almost a quarter of rural households said that high-speed access is a major problem in their area. So traditional digital divide research has focused upon these disparities in access to information communication technologies. Extended to VGI, this includes concerns about both who produces and who is represented by these geographic data sets. Preliminary research, once again, mostly based upon OpenStreetMap, has indicated that there are equity issues in VGI representation. Majority of data points created tend to be in whiter and more affluent areas. So urban forests, probably preaching to the choir here, but for our research, we defined a city's urban forest as consisting of basically all the trees in an urban area, whether they're in a park, a street, someone's yard, or elsewhere within the city. Together, they collectively constitute a city's urban forest. And once again, probably preaching to the choir, but urban forests are essential parts of cities. They provide a wide suite of both social and ecological benefits. Recreational aesthetic benefits help to conserve energy by shading and reducing the need for heating and cooling. Of course, essential in this age of climate change, help to store and sequester carbon, reduce atmospheric air pollution, help to increase property values, provide physical, psychological health benefits, reduce noise pollution, and there's even been studies showing that urban forests can increase public safety. A couple that I don't have here up on the slide that are also essential is increasing biodiversity by providing habitat, and then one that has been kind of at the forefront of urban forest advocacy, at least in the US context, and I assume in Europe as well, is the potential of urban forests to contribute to managing stormwater. So many green infrastructure plans include planting trees as a method of stormwater management, moving away from gray underground infrastructure to above ground green infrastructure, including urban trees. So how are urban forests an environmental justice issue? At its heart, environmental justice is an assessment of who wins, who loses in relationships between people and their environments. Environmental justice research and activism started out largely examining disproportionate exposure to environmental hazards, toxic waste facilities, nuclear storage facilities, other types of hazards, extended to include natural hazards, And recently, environmental justice, really since the early 2000s, has expanded its focus and also started to look at access to environmental amenities, as well as the traditional freedom from environmental hazards. So things like urban trees, urban parks, other things that improve the quality of life for urban residents. And given all the benefits of urban trees that I just presented, we can see that trees improve the quality of life for urban residents, and that makes them an environmental justice issue. All neighborhoods should have equal access to those benefits provided by urban tree canopy. And there's been a large body of research across North America and some in other places as well that has demonstrated that neighborhoods, more racialized minorities, lower incomes, have less tree canopy. So the connection with VGI, if people are creating these urban forest VGI data sets and assuming that they're actually used in improving urban forest conditions, environmental justice concerns, if it is produced by represents different groups, if there are parts of the city that aren't covered as well by these data sets, it might actually affect people's quality of life on the ground. Here we're only really able to address representation. It's not necessarily the case that VGI is produced by residents where they live. Planners are interested in using VGI in policy decisions. There's, as with the larger VGI concerns, there's a potential for VGI to make planning more participatory, more democratic, but there's also concerns about existing inequalities being deepened if digital divide issues arise. Planners recognize that official data does not include information about marginalized citizens, neighborhoods, resulting in their needs not necessarily being considered when making urban policy deliberations. VGI is seen as a potential remedy to this issue, but there remain concerns surrounding the barriers to participation in VGI creation that may result in further exclusion. There have been successful pilot studies of VGI as a participatory planning tool in places like Finland, Norway, Ecuador. And both of the VGI tree projects that I'll be discussing today are intended to inform public policy. Which leads me to my research question. Do social demographic, physical, and/or environmental factors predict the density and/or the richness of urban forest VGI in Philadelphia, San Francisco? And just some brief background on these two places and kind of why we chose them. Of course, they both had available VGI data sets, but also I think the differences between the two cities make them a rather compelling case study for comparison. Philadelphia is a recovering post-industrial city. It saw population gains in both the 2010 at 0.6% and 2020 at over 5% censuses, which were the first times that Philadelphia saw increased population since 1950, but it's still down approximately a quarter of its peak population then. So despite these signs of recovery, there's concentrations of spatialized poverty that remain. It's one of the poorest major US cities and one of the ones with the highest Gini index, which is the standard measure of economic inequality. It's also racially diverse. 44% of Philadelphia's population is African American, about 13% is Hispanic or Latino. San Francisco is a different story. They of course have a booming tech economy. San Francisco and New York were the only two major North American cities that had rebounded to the historic 1950 population levels by 2000. Philadelphia, San Francisco also has a racially diverse population, but in this case, it's approximately a third Asian American. So we have different types of differences in diversity in these two cities and a very different economic story that is interesting for comparison. In terms of our data sources, we collected the data that was publicly available on open-facing VGI websites in both cities. And we kind of parsed and cut down these data sets. There was, in both places, data that was either collected by the city or large amounts of points contributed by local nonprofits. So we were looking specifically at data that had been contributed by individuals. So we parsed the data sets that way. And then other than just the presence of trees, there's other data associated with entries, things like species, DBH, height, canopy condition, pit width, pit length, pit type, if it was underneath power lines, if it was creating sidewalk damage, additional comments people made, and some even had photos attached. So we used those other data to create basically an index of data richness. So we're looking at both data density and data richness. We used standard demographic data used in environmental justice research, median household income, education, age, ethnicity at the block group level. And then to control for the presence of trees influencing VGI data entry, we also used remotely sensed tree canopy data at a high resolution for both cities. Philadelphia was 1 meter land cover raster derived from LiDAR data in 2008. And then San Francisco was a combination of 3 meter, 1 meter, and 15.25 centimeter rasters from 2010 derived from both LiDAR and aerial photography. Finally, we used building data to control for the urban form, urban fabric, was the maximum building height in each block group. So we assessed whether asymmetries exist in data gathered through VGI urban forest mapping in 2 different ways. First, using the point data for trees mapped, we modeled the VGI tree density at the block group level in both cities, aggregating point counts to start to get at data density. Second, we assess whether there's asymmetries in data richness, measured by the number of attributes entered for each tree aggregated to a mean index of data richness for VGI trees in each block group. As is often the case with count data, the distribution of tree counts in both cities and the derivative index derived from them were dramatically skewed, false truncations at 0. Typically, count data that have this pattern and linear regression techniques are not viable options for examining correlations between these distributions and demographic, environmental, neighborhood conditions. In Philadelphia, we fit general linear models with Poisson distribution log link, treating the different dependent variables, count of VGI trees and average VGI index as count data. In San Francisco, the count of VGI trees, the data density measure was modeled as above, based upon a log length Poisson distribution, NGLM, and then the VGI tree index distribution was less skewed, allowing for OLS regression. Here we can see for Philadelphia, Philadelphia city and county is contiguous. In lighter green, the city's tree canopy, which is about 20%, and then in the darker green dots, the user contributed VGI trees. And we see right away that there's an obvious disparity, and there's obviously some spatial concentrations, right, of VGI contributed data. We have a concentration in the center of the city and a little bit in South Philadelphia, whereas most of the city's tree canopy, as you would expect, is in the city's major park systems. Fairmount Park, Wissahickon, and Tacony Creek Park. San Francisco, we see a little bit more distribution. There's not as heavy spatial concentrations of the VGI point data, but similarly, we see that the majority of the city's actual tree canopy is in the major parks, Golden Gate and the Presidio, and there's some overlap in between the two. Here is the VGI index. So once again, this is the mean at the block group level of the basically the data richness entered for VGI trees, the additional attributes that provide really invaluable information, right, to planners of the condition of the trees, their height, dBH, if they are interfering with power lines or causing sidewalk damage. So once again, we can see kind of a spatial concentration here. Here it's a little bit more in the South Philadelphia region. In terms of our model results for Philadelphia, we see a strong model fit, but there's also some explained variation implied by the high AICC. All the variables were significant at the less than 0.01 significance. Here the sign rather than the size is important for these variables. They're all log transformed to approach more normality. So we see positive predictors for both the data density and data richness, median household income, and percent 65 plus. Negative predictors of data density, data richness include education, lack of high school diploma, all of the racialized minorities, percent African American, Latino, and Asian American. It's interesting that tree canopy percent is also a negative predictor, and then the variable for building height actually flips signs between the two models. Here we see our index results, the data richness measure for San Francisco at the block group level. Once again, we see some spatial concentrations of this data richness index. The results from the modeling are more ambiguous, but median household income is still a positive predictor in both models. And then the opposite of Philadelphia, tree canopy percent is a positive predictor as well in both models. So to summarize the results in Philadelphia, median household income was positive predictor in both models. So if people are contributing more and richer data about urban trees in wealthier neighborhoods, and also if people are contributing less information in neighborhoods with higher levels of racialized minorities, there's certainly environmental justice concerns present. San Francisco, as I said, the models are more ambiguous, but median household income, tree canopy, and percent African American were positive. So results suggest that urban forest, VGI data density, and richness are influenced by social demographic factors presenting digital divide, environmental justice concerns. And environmental justice researchers arguing that access to amenities such as urban forests is an integral component, along with environmental justice, along with earlier foci and hazards and disamenities, have documented the relationships between affluence, whiteness, and increased urban tree canopy coverage for many years. Our results suggest that less affluent neighborhoods have fewer trees, both on the ground and in VGI representations. In the extreme case, VGI has the potential to deepen rather than ameliorate differentials in place-based resources devoted to certain locales through policy decisions of neighborhoods where a large portion of trees are unrepresented or neglected due to their lack of representation in urban forest VGI datasets. The uneven representation in VGI coverage extends beyond urban forests and may reinforce inequalities in representation from traditional data sources where marginalized groups and areas are not always counted. While there are concerns around privacy and surveillance both by the state and capital with the growing amount of digital traces generated through VGI and other sources, documenting the presence and condition of urban trees seems to be a positive increase in legibility. Despite the democratizing rhetoric around VGI and other Web 2.0 technologies, this research highlights their potential to reinforce rather than break down barriers in terms of representation and potential negative urban environmental consequences. There's also the difference between the two study sites in terms of especially the influence of tree canopy on VGI representation points to the need for more localized case studies. As this is a relatively new field of investigation, it's still important to get new quantitative data, new quantitative models to try to understand how and why VGI urban forest data is distributed. But following Laura Polito, it's important to move beyond solely empirical, apolitical, essentializing formulations of the digital divide and environmental justice. Moving beyond spatial abstractions of having, not having access to technologies in green spaces. While census block groups are a suitable level of analysis, they still serve to mask differences between those who live and work in census boundaries areas and do not consider the mobility patterns of individuals. Analyses based upon socially constructed demographic variables, such as race, further serve to obscure the differences within these groups based upon a multitude of factors, and miss how class, gender, or racialization are mutually constructed through place-specific lived experience. So future VGI research, future urban forest VGI research should move beyond documenting disparities in representation to theorizing why they occur, how they can be addressed if these patterns hold true at multiple scales, and allow for agency. It's largely kind of a deficit-based model presented here, but trying to understand the agency of urban residents, I would argue, is essential. So what should this look like? I'd like to eventually do some in-depth qualitative work with those who both do and don't produce VGI. Look at why people are and aren't producing volunteer geographic information. Produce VGI on what people are interested in value through participatory action research, developing VGI with communities. And finally, work with planners, policymakers to determine both if and how volunteer geographic information is actually used in policy creation. As an example, the question raised by the different influences of tree canopy coverage in the two cities on VGI data density, data richness could be addressed by qualitative research. Maybe the inconsistencies and unexplained relationships in quantitative research should be seen as opportunities for further in-depth qualitative research rather than problems. Finally, to be clear, despite the concerns I've expressed regarding the spatial distribution of contributions to urban forest, VGI maps and their data richness in both Philadelphia and San Francisco, I'm not condemning tree mapping websites, their creators and contributors, or VGI in general. Rather, attention is called to the need to ensure that these technologies are employed and utilized in manners that increase equity. There is great potential to increase data richness and the equity of coverage if care is taken. To borrow Eric Derrier's paraphrase of Michel Foucault, not everything is bad, but everything is dangerous. So thanks for having me. Thanks to my collaborators on this research, Ian Dunham at San Francisco State University now, and Strauss Kaler at Temple University. And hopefully we have plenty of time for some good discussion.
Yes, thank you very much, Alec. Yeah, I would like to give you a round of applause, but I guess it will be a digital applause still.